Hi everyone, just wanted to take a moment to talk about how to find the orthocenter of a triangle. As a reminder, the orthocenter of a triangle is the intersection of the altitudes. This is actually probably your personal favorite one to find, not necessarily because it's the easiest one to find, it's just because it's the only one that doesn't have something else going on, right? The centroid was 2/3 and um, the incenter and the circumcenter had things that were equidistant and various things like that. So this one, you're really just worrying about finding it. So let's go through the process of actually finding the orthocenter. Again, I'm keeping with those same points. All right, so now we're going to find the orthocenter. So what we need to do for an altitude is we need to remind ourselves, well, what is an actual altitude? If I draw a triangle, the altitude is going to be the distance from the vertex to the opposite side, and it is perpendicular. So, well, what do we need? Well, to find the equation of one, we need a point, which is fine. We have a vertex, that's easy enough. And we need the slope. All right. So we'll need the slope of the opposite side. And then from there, we can find the equation of our line. Well, we need the opposite slope, the opposite reciprocal. But anyway, so let's ask ourselves which slopes are easiest to find. Well, I think as we found before, the slope, let's do the slope of x and y. All right. So remember, when you're doing the slope of x and y, that would mean that z is the point that you're going through. So the point that's not included in the slope is the one that you go through. Okay. So our slope of x and y would be 5 minus 15 over 1 plus 3. It's going to be negative 10 over 4, which is negative 5/2. All right. So now if I were to talk about the perpendicular slope of that one, it would be 2/5. Okay. So there's one of them. And then from there, I guess it doesn't necessarily matter which one we're dealing with. I just did x and y, so let's do yz. Sure. Slope of yz. Okay. Change in y. Oop. Change in y is going to be 10 minus 5. Change in x is going to be 5. Whoop. It's actually kind of nice. 5/4. So my perpendicular slope here is going to be negative 4/5. And I actually don't hate that because that means both of them have a denominator of 5. So that's good to work with. Okay, so going on from here, what do I need to do? Well, I used, let's ask ourselves, what are the other points that we have involved? So we know we used yz here, I need x. So my other point that I'm dealing with is negative 3/15. Now over here, this point, I used x and y, so that means z is involved. And now let's actually find the equations of our lines. So let's do the dark blue, why not? So let's find this equation over here. Again, you should always graph it out first just to double check. The reason I didn't bother graphing this out is because this is the exact same set of coordinates I've used for all three of them, and they're not nice. Anyway, so ultimately, let's find this. Let's find it. Y minus 10 equals 2/5. I actually don't hate that. X minus 5. It's actually pretty nice, right? Because if I simplify that, that's going to be y minus 10 equals 2/5 x minus 2. By the way, when you get your equations, you can always graph them using like a graphing calculator or Desmos or something like that. I'm just going through the process of showing you what to do. Okay, so we have that. Oh, I'm going to add the 10. You know what? The reason I'm bothering with that is because that actually canceled nicely. That's the first one I think all day. The 5. Okay, well, anyway, let's look at the other one, which I know is not going to be as nice. So we have y minus 15 equals negative 4/5 x plus 3. And as I can see here, the 5 is stuck. So y equals negative 4/5 x plus 3 plus 15, which, by the way, looks very similar to a lot of different forms you've encountered in the past. I am not going to bother simplifying that for right now because why not? Maybe there's something I got rid of. All right, well, these two are both equal to y, so I can set them equal to each other. So I would have 2, oh, 2/5 x plus 10 equals negative 4/5 x plus 3 plus 15. Now, the reason I bothered to do that is because now what I can do is I can subtract the 10. So I'll get 2/5 x equals negative 4/5 x plus 3 plus 5, which may not seem like it's that much better. However, now I only have to multiply a 5 by 5 as opposed to a 15 and a 10 by 5, so I did save myself a little bit of work. All right, and plus, you off the top of your head definitely know what 5 times 5 is. Sometimes 15 times 5, you might, I mean, you can figure it out, but your brain sometimes will be like, oh, I know I have to kind of take a minute and think about it sometimes. It's not one of the regular ones that you learn about all the time. Okay, so I'm going to multiply everything by 5 because I don't want to deal with fractions. So 2x equals negative 4 times x plus 3 plus 25. So 2x equals negative 4x minus 12 plus 25. So that would make that 6x, and that's going to be equal to 13. So x is going to be 13/6. Boo! Okay. Well, what does that mean? I'm going to plug it in here. As you can tell, this was not meant to be an Orthocenter question. All right, well, 2/5, 13/6. Can I save myself anything here? Yes, I can. All right, well, that's going to be a 1 and a 3. So it's going to be 13/15. I got to make that over 15. Oh, geez. So anyway, y will equal 13/15. I am going to have to make that over 15 plus 150 over 15. So anyway, y is going to be equal to 163 over 15. Is that going to simplify it all? Let me think. Is there anything that very clearly would go into that? I don't think so. Let me just double check. No, there's nothing there. Okay, so anyway, that would be our coordinate of our orthocenter. It would be 13/6 and 163 over 15. Now, you're probably asking yourself, why did I bother to go through this and not actually just pick different problems each time, other than the sheer fact that I was too lazy to pick new points? Well, this is kind of to show you in general the worst case scenario. Most of the time you get away without having to do most of this work, right? Because if you have perpendicular lines, if you have anything that's vertical or horizontal, bam, you basically figured out how to do this, right? Because if you have a horizontal line, the vertical one would be perpendicular. You have a vertical line, horizontal line, perpendicular. Okay, and then you already have one of your x and your y's. Okay, and remember, if it's a right triangle, your orthocenter is going to be at your right angle. So you can usually get away with doing a lot less work, but I just wanted to show you the worst case scenario of you just taking some random triangle and figuring out what to do with it. All right, let me know if you have any questions, and have a great day.